Good morning, guys. We're going to just talk briefly about an example from the previous lesson on arithmetic sequences, and it wants to know which lists four consecutive terms of an arithmetic sequence. Remember that an arithmetic sequence will always have a value d, which is called the common difference. So what we would need to do is to find that common difference for each problem and then check to see if it actually is arithmetic. So on answer A, I'm going to take second term minus the first term, which means that if this is arithmetic, when I add 7 to each term, it gives me the next term. And I've proven 3 plus 7 is 10, 10 plus 7 is 17, 17 plus 7 is 24. So this would be an arithmetic sequence. On B, if I find that common difference, I'm going to take the second term minus the first term, and it gives me 3. And I'm going to check to see if that works. 1 plus 3 is 4. 4 plus 3 is 7. Does not work. On C, to find D, I'm going to take second term minus first, and it gives me 1. So if I add 1 to each term, it should give me the next term. 1 plus 1 is 2. 2 plus 1 is 3. Doesn't work. And on D, I would find that common difference, 6 minus negative 5, which is 11. I would add 11. And that does equal 6, but 6 plus 11 equals 17, and that is not arithmetic. Therefore, your correct answer would have been answer A. All right, in this lesson 4.03, we're going to be looking at geometric sequences. And geometric sequences are similar to arithmetic, except you have a common ratio. And to find the common ratio, you are always going to take the second term divided by the first term. So in an arithmetic, you're adding or subtracting. In a geometric sequence, you are going to either be multiplying by a certain number. All right, so let's look at example 1. We have the sequence 3, 9, 27, ... which means it is infinite. I'm going to find the value of r, and I'm going to use the second term divided by the first, and I find that r is equal to 3. So this is a geometric sequence because if I multiply each term by 3, it will give me the next term. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. In the second example, you have a sequence of numbers, 3, 1, 1/3, 1/9, ... and so on. And we're going to find r. R is going to be the second term in the sequence divided by the first term, and we get a fraction. But we've got Desmos, so not any problem multiplying to check to see if this works. I'm going to do 3 times 1/3, and it equals 1. 1 times 1/3 equals 1/3. 1/3 times 1/3 is 1/9. So this is an example of 2 geometric sequences, one which has a common ratio that is an integer and one that is a fraction. All right, just like in arithmetic sequences, in a geometric sequence, you're going to have 2 formulas. They are going to be on that formula sheet. You will have an explicit formula and you will have a recursive formula. The explicit formula for a geometric sequence is a sub n is equal to a sub 1 times r to the n minus 1, where a sub 1 is the first term, N is the term number, and that would be like if you were finding a sub 5, the fifth term, N would have a value of 5. And R is going to be that common ratio. And to find that common ratio, we are going to be doing the second term in the sequence divided by the first term. All right, remember from arithmetic sequences that the recursive formula is using your previous term, and the previous term in this formula is represented by a sub n minus 1. So this is going to be your previous term. N is going to be the term number, and R is going to be that common ratio. And just like in the explicit formula, to get that common ratio, we're going to take that second term divided by the first. All right, we are given a sequence, and we are told it is a geometric sequence, and they want us to write both the explicit and the recursive formula. So what I would have to know is which formula goes with which one. The explicit is a sub n equals a sub 1 times r to the n minus 1 power. To write this formula, we have to know what a sub 1 is. We have to know what r is. Okay, a sub 1 is no problem. A sub 1 we know is the first term, and the first term in this sequence is 3. To find r, we are going to take the second term, and we're going to divide it by the first. Second term is 2. First term is 3. And that gives me the fraction 2/3. So now, once I know those two pieces of information, I'm ready to write my explicit formula. My formula is going to be a sub n is equal to a sub 1, which is 3, times r to a power. Anytime that we raise something to a power, we should always put it inside parentheses. So in this case, my r is going to go inside parentheses, and it is going to be to the n minus 1 power. To my explicit formula, a sub n equals 3 times 2/3 to the n minus 1 power. To write the recursive formula, the only thing I have to know is the value of r, and the value of r we have already found, which is 2/3, and my formula is going to be a sub n is equal to r, which is 2/3, times a to the n minus 1, sub n minus 1. All right, which sequence is not geometric means that I'm going to be finding the r value for each of these. So in A, I'm going to take the second, I'm going to divide it by the first, and I'm going to get -4. Then I'm going to multiply. -1 times -4 does equal 4. 4 times -4 equal -16. -16 times -4 is 64. So this one is geometric, and we're looking for the one that is not. On B, I'm going to find R. I'm going to divide second term by the first term, which is going to give me a ratio of 2. I'm going to check now to see if this is geometric. If it is, if I multiply each term by 2, it should give me the next term. 1 times 2 is 2. 2 times 2 is 4. And because this number is 6, that means this one is not geometric, and that would be your answer. I'm going to go ahead and do C and D. C, your ratio would be second term 4 divided by the first term 2, which is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So this one is geometric. And on the last one, to get my ratio, I'm going to take the second term, which is 1/3, and I'm going to divide it by the first term, which is 1/2. And I'm going to find that my ratio is 2 divided by 3 on Desmos. I'm going to multiply by 2/3, and I get 1/3. 1/3 times 2/3 is 2/9, and 2/9 times 2/3 is 4/27. So the one that is not is answer B. Right, in this question, we are given a sequence and we are asked to find the common ratio. We know the common ratio is found by taking the second term and dividing it by the first term. The second term is -4. I'm dividing by the first term, which is 2, and my answer is -2, which would have been answer B. All right, another example of finding the common ratio. Again, the common ratio is the second term divided by the first. That's going to be 25 divided by 125. And when I simplify that on Desmos, I get 1/5, which is answer C. All right, we are asked in this problem to find the explicit formula, and I've written the explicit formula for a geometric sequence. A sub n is equal to a sub 1 times r to the n minus 1 power. We have to know what a sub 1 is. A sub 1 is the first term in the sequence, which is 3. And we have to know what r is in order to write this formula. So to find r, I'm going to take the second term, which is -12, divided by the first term, which is 3, and I get a value of -4 for r. At this point, all I'm going to do is just plug in those two values into this formula. I have a sub n is equal to a sub 1, which is 3, times r to a power, and we always put a number in parentheses that we're raising to a power, and this would be my explicit formula. A sub n is equal to 3 times -4 to the n minus 1 power, which is answer D. All right, what is the fifth term of the sequence with a first term of -2 and a common ratio of 1/4? And we have to make a decision. Is it easier to use the explicit formula, or is it easier to use the recursive formula? And to find the fifth term using the recursive formula, I would have to know the fourth term. I do not. The third term, I do not. The second term, I do not. So I would have to find all of those terms. So it makes more sense to use our explicit formula, which is going to be a sub n equals a sub 1 times r to the n minus 1 power. And to use that formula, I'm going to define the information that I am given. I'm looking for the fifth term, so I know n is 5. The first term, a sub 1, is -2, and the common ratio is 1/4. So I'm going to plug that information in. I have a sub n, and n is 5, which means I'm looking for the fifth term, is going to be equal to a sub 1, which is -2, times r, and r always goes in parentheses, to the n, which is 5 minus 1 power. If I simplify this, this is going to give me -2 times 1/4 to the 4th power. I'm then going to type that into Desmos. -2 times 1/4 to the 4th power, and that would give me -2 times 1 over 256, and then I multiply to get negative 1 over 128, which is B. Right, in this example, it asks for a specific term, an explicit term, the 14th term, so I know that my n has a value of 14. I know my first term, it is 3. I can find my common ratio, the second term divided by the first term, which gives me a value of 3. Because I'm looking for a specific term, I'm going to use the explicit formula. A sub n is equal to a sub 1 times r to the n minus 1 power. N is 14, so I have a sub 14, which means I'm finding the 14th term, is equal to a sub 1, which is 3, times r, and remember that r goes into parentheses, to the 14 minus 1 power. So I have 3 times 3 to the 13th power. Mocha? Where's Mocha go?
Right here.
I heard her whining. I had to come in here to use Desmos. Because I don't know what 3 to the 13th power is. Do you know it? 3 parentheses 3 raised to the 14th power. Okay. 1, 4, 3, 4, 8, 9, 0, 7. One more slide to do on this. Okie dokie, honey. Love you. When I type this into Desmos, I get a really large number because 3 to the 13th power is going to be extremely large, and my final answer is 14,348,907, which is answer A. All right, we are asked to find the explicit geometric formula if we are given the recursive formula, and to the side I have written what your form is for the recursive formula. Notice that R, which is your common ratio, is in front of A sub n minus 1, which means in this case that negative 2 is going to represent R. Whatever is in front of that previous term, A sub n minus 1, is the value of R. So I have A sub 1 is 3. I know R is negative 2. I'm going to write my explicit formula, which is going to be A sub n is equal to A sub 1 times R to the n minus 1 power. And I'm going to plug in these two values. So I have A sub n is equal to 3 times R, and remember R is going to go in parentheses, to the n minus 1 power. So my correct answer would have been answer B. Remember that I do have the formula sheet posted. I would suggest going ahead and printing a copy of that if you can, so that you will have it easier to access when you're doing your quizzes and your test.